Hello boys and girls, welcome to Science in Daily Life with Sarzami. I trust that you're doing quite well today, because I would have promised you in your previous class that in today's lesson we will be doing some fun stuff, some fun and exciting scientific experiment. But before we proceed in today's lesson, can you recall what we have done in our previous class? Yes, we would have classified acids, stated uses of acids, and finally, we would have differentiated between acids and bases. In today's lesson, we will be looking at reaction of acids. Our objectives would be to investigate the reaction of acids with metal and bases, and lastly, to explore what we call neutralization reactions. Acids are very reactive substances. For example, they react with wood, paper, cloth, plant materials, plastics, and coins. Some reactions are vigorous, while others are slow. However, many factors, including the strength of acids, determine the extent of a reaction. Today, we'll be doing some reactions of common acids with substances such as metals and bases. These reactions are important to us since most of the materials we use are made up of or include these substances. What do you think happens when an acid reacts with a metal? Have you ever noticed what happens when acid drops on a coin or a nail? Perhaps you would have observed or not, but let us do a little experiment here on what would be expected to happen. Now, what I have here, I have a dilute sulfuric acid. It's here in my container, my glass bottles rather. I have in here magnesium powder. And what I will be doing, I will add a few drops of sulfuric acid into my magnesium powder. So what I'm reacting here is an acid, which is sulfuric acid, and metal, which is magnesium. Now, what I want you to observe, after I would have dropped my sulfuric acid into the magnesium powder, I will light a match and place it just over the mouth of the test tube. I want you to pay close attention to what would happen. So let's get straight into the activity. So as I would have said, I will take a little bit of sulfuric acid. And this would be so much fun with you having a lab partner with you. So you and your lab partner can cautiously perform this experiment. So I will simultaneously be doing it since I don't have a lab partner here with me today. I will light my match before I drop my sulfuric acid into the magnesium. Alright, so let's see what will happen. Pay attention. Ooh, you see that reaction happen very vigorously there, isn't that so? And if you had listened a little bit closely, you would have heard a pop sound. Because that pop sound indicates something was being released after the reaction would have occurred. Alright, so let us move on. Now, what is produced when an acid reacts with a metal? What is actually being produced is hydrogen gas as well as a salt. So let me repeat that one more time. When an acid reacts with a metal, we have a salt being formed as well as hydrogen gas. When I would have lit the matchstick and placed it over the mouth of the test tube, hydrogen gas would have evolved, which caused the matchstick or the flame to give a popping sound. Please note, boys and girls, be very careful as hydrogen gas exposed to flame is explosive. What we did here today, we just used a little bit of magnesium and then just a few drops of sulfuric acid. And that is why I was able to use my matchstick, right? Because if we would have used it in a large quantity, this would have been very, very harmful, as it would have caused an explosion. So please take note of that. Now, let us move on. Since we know now that when an acid reacts with a metal, we have hydrogen gas being given off, let us look at how some various metals would react with acids. What I will be doing now, my next activity, I will be reacting 4 metals with hydrochloric acid as well as sulfuric acid. What I want you to do is to see how the reaction occurs. If it occurs at a vigorous pace, or it occurs at a slow pace, or there's even no reaction at all. So I'm just going to outline the method for you, so please pay attention. First, we have to pour the dilute acid into a test tube to a depth about 3 cm. But what I would have done in this case is I would have already measured out my metal and placed my metal into the test tube. So in this case, I'll be dropping my acid into the test tube. You can also place the acid within the test tube and then you can drop your metal into it. Now, after that, we will be observing carefully what happens after that reaction takes place. So let's get straight into it. I will place it into my beaker here for you to get a better view of what is happening. So I have here my first metal, magnesium. I'll be using magnesium. I'll be using iron filings, copper, as well as zinc. So I have them here in order so I don't get mixed up. Now another thing that I want you to take note of, students, be very careful not to contaminate your stuff, right? So to avoid contamination, as you can see, I placed my chemicals far apart. I have 2 different syringes that I'll be using. One will be used only for the sulfuric acid and the other one will be used only for hydrochloric acid. Okay, boys and girls, let's get straight into the activity. So I have here, as I have mentioned, my magnesium, and now I'm going to drop a few drops of sulfuric acid. So pay attention. Please note what you're looking at is how vigorous or how slow or if none at all reaction will occur. So let us go. Right? Look at that. Wow. That is sulfuric acid as well as magnesium. Let us light our match and see if we'll hear that popping sound like before. Alright, so I guess the gas has already escaped. We will try and see for the others. Please remember, if you have a partner when you're in school, more fun. Okay, boys and girls, let me remove my magnesium. And now I'll move on to my iron filings. Sulfuric acid. Alright, as you can see, if you can see, it's slowly coming up. So you can see it slowly came up, right? So let's now go to my copper. As you can see, we don't really have any reaction occurring. So this is like a no reaction. Okay? Lastly, students, we will look at zinc. Sulfuric acid to zinc. Oh, look at that. Let me try and see if we can capture some hydrogen. Woo! You saw that and you heard that. Excellent. That's your popping sound. That is what I would have expected you to hear at the first instant we would have done it. Alright. So, this will end the first half of the activity where we will have reacted sulfuric acid with 4 different metals, namely magnesium, zinc, iron, and copper. So, let us now go to reacting these metals with hydrochloric acid. So we're going to use a different acid to see if the reactions will be the same, if there will be any difference. So let's go straight into that. Turn this stuff this way. So I'm going to start, okay, we need to return that there. So I have my dilute hydrochloric acid with a different syringe because we do not want to cause contamination. So we have magnesium first. We're just going to pull up, add a few drops. Whoa. As you can see, I don't know if you can actually see it, but you can actually see the gas being evolved. Right, now of course if we add a little bit more, look at that. Right, so imagine now if we would actually light that match, it would be poof, or pop I should say rather, a huge popping sound would occur. Now please also take note that the tester will be a bit hot. Alright, because a lot of heat here is being evolved and given off. So you need to use your safety gear when you're in the lab conducting these experiments. Alright. See, it's kind of still reacting. Now let us move on to our what? Our iron filings. So let us go. As you can see when I'm shaking it up, we have a very slow reaction occurring. This is exactly what happened earlier, right? So, yeah. Good. Let's go to our, and if I may show you, my magnesium is still reacting. Yeah, let's go to copper. Once again, we have no reaction. And lastly, we have our zinc. So let us go. Boy. We also have another vigorous reaction occurring there. Alright, I'm going to place my hydrochloric acid away. Place my syringe next to it. Let's see if we can have a last popping sound for you. Woo, there we go again. Excellent. So students, the big question is now, right? The big question is, out of these four metals, which one actually reacted the most vigorous? Which one reacted the least? Or, as we can vividly see, had no reaction at all. So our four metals are magnesium, iron, copper, and zinc. So you can drop a nice little table, for example, this one, where we have metal, dilute hydrochloric acid, as well as dilute sulfuric acid, and you can actually put in your observation. Now this activity is called a qualitative activity because we're taking our data qualitatively by what? Observation. Hence you may say, sir, how much you would have dropped? Now, I would have done 3 to 4 droppings of each acid into these metals to just get the reaction, to get an idea of how vigorous these reactions occur. Now, let us conclude this lab activity, or this practical activity rather. Definitely we saw magnesium and we saw zinc reacting as soon as that acid would have touched it, or touched them. But which one would you consider to have reacted more vigorously? Yes, boys and girls, if you would have said magnesium, you are correct. Because magnesium was the most reactive metal among these four in today's activity. What would have been the second? Definitely zinc. And after zinc, we would go to iron and then copper, which we saw had little to no reaction at all. So my fun and exciting scientists, to conclude this activity, we would have had magnesium first, followed by zinc, then iron, and lastly copper. What we would have formed here is what we call a reactivity series by placing the most reactive metal to the top being magnesium and the least reactive metal to the bottom being copper. Moving on, boys and girls, another thing that we can conclude, or another fact that we can conclude, is that when a metal reacts with a dilute acid, we have a metallic salt being formed as well as hydrogen. For example, sulfuric acid, when we react that with magnesium, we have magnesium sulfate being formed as well as hydrogen gas. Copper would be copper sulfate plus hydrogen gas. When we react with hydrochloric acid, the name of the salt will change. When magnesium reacts with hydrochloric acid, we have what's called hydrogen chloride and hydrogen gas. And when copper reacts with hydrochloric acid, we have copper chloride and hydrogen gas. So it depends on which acid we react these metals with will give us the name of those salts. We have discovered what happens when an acid reacts with a metal. Now we will be looking at reactions between acids and substances called bases. As you have learned, bases are substances which turn red litmus blue. This tells us that bases are opposite to acids. We have also learned that there are two types of bases. Those which can dissolve in water and those which cannot. Can you remember what would be the pH range of an alkaline solution? Yes, from 8 to 14. Quite true. But what happens now when we react an acid and an alkalis? What occurs? To show you how this will occur and what will happen, I would like to direct your attention to a video. So please pay attention. Do enjoy.
In this practical, we're going to carry out a neutralization. You need to check with your teacher that you've got all the safety information and filled out the safety slide on the PowerPoint or written down the safety advice in your practical book. We are going to neutralize 20 ml of hydrochloric acid using sodium hydroxide, both the same strength, 2 moles per litre. First, measure 20 mils of 2 moles per litre hydrochloric acid, ensuring that the meniscus is sitting on the 20 ml mark, and pour this into your beaker. So that we can know when the reaction is over, when the acid is completely neutralized. We add 5 drops of universal indicator to keep track of the pH. It should be completely neutralized when the pH is 7. We start our neutralization by adding most of the required sodium hydroxide, so I'm going to add 18 mils, ensuring that the meniscus sits on the 18 ml line at eye level. Add the sodium hydroxide gradually and note any colour changes that occur. We then add sodium hydroxide gradually, a drop at a time, until we have reached the pH of 7, in which case all the acid will be neutralized and hopefully there will be no extra sodium hydroxide added. Again, noting any color changes that occur along the way, as you may be required to explain what is causing the colors to change. In terms of the acid particle, the hydrogen ion, and the base particle or hydroxide ion. Notice that the changes are occurring now. We have to slow right down, as one drop can in fact make quite a difference. I'll just add another half a drop to that. And there we have our universal indicator colour indicating a pH of 7. The acid should all be neutralised and there should be little or no leftover alkali in that reaction mixture. To get our solid sample of the salt that's formed, we'll need to place this into a boiling dish and place it over the heat and boil it for 1 minute. To get a solid sample of our salt, we place our reaction mixture into an evaporating dish and put it over the heat and boil it for approximately a minute just to reduce the amount of water in there. We then leave it to cool over the next few days and for the salt to crystallise. So, light up your Bunsen, ensure you've done a safety check on the hose, the ear hole is closed and you light it in a safe way. If you're using a flame, you have your flame ready before the gas arrives, and then you turn on the gas and a little bit of air in there so that we don't get a smoggy room. And then we heat this to boiling and boil it for 1 minute. Possibly a bit more depending on what your teacher says. In the meantime, have yourself a petri dish labelled. We're going to transfer our solution into there because over the next few days you may do several of these and we have not got enough evaporating dishes, so we're going to let the solution crystallise in a nice clean petri dish. Make sure it's labelled on the underside. This solution has now been boiling for 1.5 minutes. I can actually see the volume has gone down a little bit, so I'm going to take it off the heat and of course turn off the flame. Don't forget always to turn off the gas tap and never blow a Bunsen burner flame out because the Bunsen is still running. Right. Allow this to cool and then transfer it to the petri dish and put it away where your teacher directs. Over the next few days you should end up with several of these dishes crystallising different salts.
Welcome back, boys and girls. I do hope you found that video very informative. Nevertheless, let us talk a bit of what you would have observed in that video. When you use the universal indicator, you would have had to read off the volume of acid from the table that corresponds to the green color and the pH of 7. However, if you would have used litmus paper, you may find it difficult to determine the pH at each step. You should take advantage of the sudden change in color of the indicator. That is why in the experiment we will use our universal indicator. So we could have actually determined when the solution would have turned to neutral. Now, according to the video, what volume in cm³ of hydrochloric acid was added before the pH of 7 was reached? To answer this question correctly, that activity can also be repeated. But this time, when you have added 1 cm³ less than in the first case, you add drop by drop until the sudden change is seen. This is the volume of hydrochloric acid that is required to bring the pH of the solution to 7. At this stage, the amount of acid was just enough to react with the alkali present in the solution. That is, all the acid and alkali have been used up. What is therefore left or produced in a neutral solution has a pH of 7. The acid is said to have neutralized the base. That is, wiped out the effect of the base. The acid itself has become ineffective. This process, which produces a neutral solution, is known as neutralization. So, when an acid reacts with a base, we have a neutralization occurring. And according to our pH scale, the color of green would indicate a neutral solution. So that is the reason why we would have done that experiment, or you would have seen that experiment to indicate what volume of acid is required to neutralize the base. You would have noticed that the solution has no effect on the litmus. This means that the solution is neutral. This solution is indeed different from the acid and base that we started with. This proves that a chemical change has taken place and a new substance is formed. The substance formed is a white solid and it looks like salt. Indeed, it is the common salt used in our kitchen. The other substance formed is water, and this evaporated, leaving the salt. This salt, called sodium chloride, was produced from hydrochloric acid and sodium hydroxide. Hydrochloric acid plus sodium hydroxide gives us what? Sodium chloride and water. If other acids and bases were used, other salts would be formed. Please remember, in experiments like this, do not taste the salts. Some salts have an unpleasant taste. The salts formed from hydrochloric acid are called chlorides, while those formed from sulfuric acid are called sulfates. That is what I would have explained earlier when we did our reactivity series. In addition, those formed from nitric acids are called nitrates. The first part of the salts named come from the base that is used. For example, if magnesium hydroxide is used with hydrochloric acid, the name of the salt is magnesium chloride. However, if sodium hydroxide reacts with the hydrochloric acid, the salt produced is called sodium chloride. Whenever an acid reacts with a base, a salt and water only are formed. A salt and water are therefore what? The products of neutralization of an acid and a base. All salts can be prepared or made by neutralizing a base by an acid. These chemicals called salts are very important. Can you recall some uses of salts? In our homes, we use common salts to flavor our foods. Saltpetre, which is potassium nitrate, is used to preserve meat. Epsom salt is used by us as a medicine. On the other hand, in agriculture, the farmer uses salts such as ammonium sulfate, calcium sulfate, and ammonium nitrate as fertilizers. In industries, chemicals such as ammonium chloride are used in the making of batteries. Now we will look at a final video on neutralization, in which you will see how neutralization benefits us in our everyday life. So do enjoy.
Eddie bumps into Michael in the personal care department of a hypermarket. Eddie asks, "Hi, Michael. What are you doing here?" Michael replies, "Hi, Eddie. I'm helping my mom buy some toiletries. See, here is the list." Eddie says, "Toothpaste, shampoo, face cleaner, and detergent. Wow, your mom is an alkali lover." Michael asks, "What do you mean? Are all these products alkaline?" Eddie replies, "Exactly, Michael." Michael is curious and asks again, "If we apply alkaline products onto our body, does it hurt?" Eddie says, "Not really, Michael. You see, parts of our body are acidic, so these alkaline products will neutralize the acidic parts of our body. Michael asks, how does it work, Eddie? Eddie explains, when we wake up in the morning, our mouth is acidic. The acidity is due to the action of bacteria that produces acid. Toothpaste contains alkaline substances that can neutralize the acid produced by bacteria. Face cleaners, which are alkaline, make the face skin dry after cleansing. Because of that, we have to apply a toner after the face wash to neutralize the skin. The secretions in our hair make it acidic, and this prevents the growth of fungi and bacteria. When washing our hair with shampoo, the alkali in the shampoo will neutralize the acid in our hair. Michael asks, what about detergents? I suppose the alkali in detergents has the same effect on fabrics? Eddie answers, yes, Michael. I believe your mom is using the fabric softener after washing the fabrics. A fabric becomes alkaline when it is washed with a detergent. The fabric softener, which is acidic, can reduce the pH level of the fabric. Michael says, wow, neutralization is so common in everyday life. Eddie answers, there's more. Neutralization, which is a chemical reaction, is also applied in the agricultural and industrial sectors. Slaked lime or calcium hydroxide is an alkali. It is used to treat acidic soil so that the soil is suitable for plants. The action of slaked lime on acidic soil is a neutralization process. Acidic industrial discharges can be treated with alkalis in the treatment plant before being released into the river. Acidic discharges are harmful to aquatic life. Michael says, Eddie, it scares me when I think about the acids and alkalis found in the things we use every day. Eddie laughs and says, come on, Michael. Most products contain only mild acids or alkalis, so it won't hurt when we touch them.
Welcome back, my fun and excited learners. I do hope you would have enjoyed that video and you would have seen how much science is around us. Hence the name of our show, Science in Daily Life. According to that video, you'd have seen that toothpaste is an alkali, which is used to help our teeth from gaining plaque, which are caused by bacteria. So the bacteria make our teeth acidic, and the toothpaste will help us in neutralization, or neutralizing that acid. Next, you'll have seen that after you have washed your face becomes a bit dry. The face wash is mostly alkaline, and in order to neutralize that, we use a toner. Our hair, secretions in our hair is acidic. In order to neutralize that, we use shampoo. And the fabric softener is an acid, because what happens is that when we wash our clothes with detergent, those detergents are mostly alkaline. So a fabric softener is used to help neutralize that reaction. And you will have seen as well how it's used in agricultural purposes. Now, another thing that's very important to note. Chemicals or substances that contain mild acids or alkalis wouldn't hurt because we use them on an everyday basis, but of course, in large quantities, it definitely will. Okay, boys and girls, we had a mouthful today. We did a lot of activities and you have looked at a lot of videos. So it's time now for us to conclude. Today, we will have investigated the reaction of acids with metals and bases. And lastly, we will have explored neutralization reactions. Do join me next time as we continue experimenting on acid-base reaction. I am Sir Zamin and I wish you a blessed remaining of the day. Bye-bye.